Don't turn around. If the laws of physics are truly efficient, the room behind you should not exist right now. It should be a black void. It sounds insane, but your computer does this every day. Video games use a trick called Frustum Culling. To save memory, they delete everything the player isn't looking at. And for the last 100 years, quantum mechanics has been hinting at a terrifying possibility. Reality is doing the exact same thing. Here is why the universe might be deleting the world behind your back. To understand the code, we have to understand the budget. The universe appears to be suspiciously efficient. It refuses to waste energy painting the darkness where no one is looking. If we assume the world is fully furnished and static even when we turn our backs, we are assuming the universe has infinite processing power. But nature rarely works that way. Nature creates the maximum result with the minimum effort. This brings us to the architecture used in high-end real-time graphics simulations like Unreal Engine 5. Developers call it Frustum Culling, but it is essentially a rule of economy. The engine projects a viewing cone, a frustum, from the player's eyes. Inside the cone, the world is rendered in 4K resolution. But outside the cone, the engine doesn't just hide the geometry, it purges it. It deletes the objects from active memory to prevent the system from crashing. The world outside your vision isn't solid. It is merely a potential waiting to be loaded. For a century, physicists have stared at the quantum world, baffled by its refusal to behave like solid matter. We label this behavior spooky, weird, or anomalous. But if we swap the lens of a physicist for that of a software engineer, the mystery starts making more sense. These aren't anomalies. They're artifacts of a system designed for aggressive optimization. Quantum mechanics suggests that reality isn't fully there until it needs to be. It renders what matters, when and where it matters. Let's look at the evidence. The quantum world doesn't behave like stuff. It behaves like potential. Unobserved, a particle has no single position and no single velocity. It exists as a wave function, a probability cloud. In computing terms, it's a variable that hasn't been assigned a value yet. The system is storing possibility, not committing to a single coordinate. Then it hits a detector, and everything snaps into place. One outcome, one reality. Yuri Ozhagov of Moscow State University proposed an idea he calls the limitation of computational resources. The premise is simple. The universe may not have infinite memory. Maintaining the complex, entangled phase relationships of a quantum system is exponentially expensive. Which leads to the question, what does a finite system do when the cost spikes? One speculative but fascinating idea is that the universe runs on a finite budget. Tracking every superposition is a memory hog. So when a system becomes too complex or interacts with the environment, the universe executes a forced optimization. And what's left is the stable, classical world we're familiar with. Rocks, tables, hard edges. Not because it's the deepest truth, but because it's the version of reality that the universe can keep running. If we are living in a computed environment, there must be hardware limitations. A simulation cannot be continuous. It must be discrete. It must be pixelated. And physics gives us a candidate for the pixel. We call it the Planck Length. It is approximately 1.6 times 10 to the minus 35 meters. This is not just a small number, it is a hard-coded limit. Physics tells us that attempting to measure anything smaller than this length is impossible. In principle, it would require so much energy that it would collapse into a microscopic black hole. The universe effectively censors any attempt to see the subgrid. It creates an event horizon to prevent you from seeing the pixels on the screen. Then there is the latency issue. In a grid-based processing network, information cannot travel instantly. It must propagate, node by node, across the lattice. We call this latency limit c, the speed of light. We often think of c as the speed at which photons travel, but that is a secondary effect. C behaves like the speed limit of causality, the maximum speed of the universal processor. For a full video on why the universe has a speed limit, see the link in the description below. Now, no update can happen faster than the grid can refresh. The vast distances of space are not just empty volume. They are loading times enforced by the processing speed of the substrate. So, what is the machine made of? John Archibald Wheeler coined the phrase "it from bit," and he meant something precise. The physical world is built from answers, not human answers, outcomes. At the deepest layer, reality, the it, does not present itself as a continuous substance. It presents itself as forced decisions, the bit. Up or down, here or there. This interaction happened, that one didn't. Each measurement is a yes or no event that pins down uncertainty into a definite fact. MIT physicist Seth Lloyd took this literally. He argued that the universe doesn't just contain information, it processes it. The laws of physics are not mystical forces acting on inert stuff. They're the update rules, the logic that transforms one state into the next. And what we experience as matter is what those rules look like from the inside. Matter is the picture on the screen. The real machinery is the code itself. One quick clarification before we test this idea against Einstein's favorite objection. When people hear reality renders when observed, they often jump to the wrong conclusion, that human consciousness is the render button. That is not what physics says. In quantum mechanics, a measurement doesn't require a mind. It requires an interaction. A photon hitting an atom counts. A detector counts. Anything that forces information into the world counts. So the universe isn't optimizing for you. It's optimizing for causality. It only commits to a definite outcome when the system needs one to keep the story consistent. You don't create reality with your mind. You're just one more process that queries the state. Now we can ask Einstein's question without the usual trap. He famously asked a colleague, "Do you really believe the moon is not there when you're not looking at it?" If reality is a rendering engine, the answer is not a simple yes or no. It depends on what you mean by moon. If you mean the silver sphere, the cratered gray texture, the photons reflecting, then no. That is the rendering, the screensaver. To render the visual image of the moon when no one is looking at it would be a waste of the universe's precious energy. But if by moon you mean the data, the mass, the gravitational well, the tidal potential, then yes, the code is always there. The file sits on the hard drive of the cosmos, dormant, unrendered, invisible. It waits in the dark, conserving resources, keeping the possibilities on standby. It waits for you, or a telescope, or a stray asteroid to interact with it. You don't summon reality with your mind. You just click, and the universe opens the file. If you like science that makes you rethink reality, feel free to subscribe to get more videos like this one. And let me know in the comments, if the universe only renders when needed, what's one thing you suspect is mostly unrendered right now? Thanks for watching. Be kind to each other, and take care.